At the very heart of what an actuary does is this huge challenge, making massive financial decisions about a future you just can't know for sure. We're talking about promises, like pensions or insurance payouts, that might not happen for decades. So how on earth do you steer a financial ship through that kind of fog? That really is the billion-dollar question, isn't it? I mean, if you could perfectly predict the future, you wouldn't need things like insurance or pension funds in the first place. But of course, you can't. So what you need is a system, a framework for making the absolute best decisions you can with the info you have right now and for adapting when that future finally shows up and looks different than you expected. And this is the tool for the job, the actuarial control cycle. It's the professional compass that actuaries use to navigate all that uncertainty. The key thing to remember is that it's not a one-time calculation or some static formula. It's a dynamic, living, breathing process for managing risk. So, here's what we're going to cover. We're going to walk through the whole cycle, step by step. We'll start with what it is, then we'll dive into specifying a problem, developing a solution, and, this is the really crucial part, monitoring the results. And finally, we'll see how it all loops back on itself to create this continuous learning process. Okay, so what is this thing, really? At its core, the actuarial control cycle is a way of thinking. It's a logical path that guides you through identifying, analyzing, and managing financial risks over the long haul. It makes sure that decisions aren't just made and then forgotten about, but are constantly checked and refined over time. Everything starts right here. Before you can even think about solving a problem, you have to define it with crystal clarity. What's the goal? What risks are we dealing with? And maybe most importantly, who's involved? Who are the stakeholders here? Let's use a company pension scheme as an example. When you look, you realize there's a whole cast of characters involved. You've got the sponsor, that's the employer who's paying in. You have the members, the employees and retirees who are counting on that money. And then you have trustees, regulators, auditors, even the government. They all have a stake in the outcome. And this is where it gets really interesting and really tricky. There's a natural tension here, right? The sponsor wants to keep costs under control. The members want to know their benefits are 100% secure. The trustees are stuck in the middle, trying to balance both of those things. And all the while, the regulator is watching to make sure everyone plays by the rules. The actuary's job is to somehow find a path forward that works for everyone.
All right, so we know the what and the who. Now it's time to figure out the how. This next stage is all about building a solution, and that means modeling the future. It's about picking the right kind of model and, most critically, choosing the assumptions that are going to fuel it. It's a very structured process. First, you pick your model. Then you feed it assumptions, about things like life expectancy, how much investments will return, inflation, and so on. But once the model spits out the numbers, you don't just stop there. You have to interpret them, to ask, okay, so what does this actually mean for the sponsor? What does it mean for the members? And this is a perfect example of why those assumptions can't be set in stone. Imagine an insurance company that's always sold car insurance through brokers. Now they want to launch a new online business. Well, they can't just copy and paste their old assumptions, right? The online market is probably younger, more urban, with totally different driving habits and risks. And the costs are completely different. No more broker fees, but way higher costs for IT and advertising. Every single change in the business demands a fresh look at your assumptions. Okay, and this brings us to the most critical part of the cycle, and really the focus for us today, monitoring the experience. This is where your beautiful, carefully crafted model smacks right into the messy, unpredictable real world. Let's frame this with a story. Imagine a colony ship, the Aurora's Echo, on a decades-long journey. When it launched, the models were perfect. But space doesn't always follow the plan. The captain of that ship, Mirave, said this when her crew started to get nervous. And it's such a profound point. A model is not a crystal ball. It's a map. It's your best guide based on what you know. But when the world you're moving through, the terrain, changes, you absolutely have to update your map. If you don't, you're flying blind. And that is exactly what we mean by monitoring and feedback in the actuarial world. It's this systematic process of checking in with reality. You constantly compare what actually happened to what you thought would happen. You dig in to understand why there's a difference, we call that a variance, and then you feed that new information back into the whole system. So check this out.
On the left is the plan for the Aurora's Echo. They assumed constant sunlight, expecting a nice 3% gain in their food supply. But on the right, that's reality. A dust nebula blocked the light, causing an 8% loss. This is the exact same kind of problem an actuary faces. Your pension model might assume salaries will grow at 3%, but what happens when unexpected inflation hits and they actually grow at 5%? In both cases, a key assumption turned out to be wrong, and that miss has a real, measurable impact. And the thing is, these variances, they almost never happen in a vacuum. They can set off a chain reaction. On the ship, the food shortage wasn't just a numbers problem. It led to bad morale and people not showing up for their shifts. We see the same kind of domino effect in insurance. It's called the underwriting cycle. Big profits attract new competitors. That competition pushes prices down, which crushes profits, and then companies leave the market, which makes prices shoot back up. It's a feedback loop. One little variance can kick off a huge cascade. So you spot a problem. What's next? You can't just stare at it. You have to act. On the ship, Captain Vey took action. She diverted some power to grow lights, started a new plan to reduce waste, and put up dashboards to keep everyone informed. In an insurance company that sees a spike in car claims, the response might be to investigate fraud, send cars to cheaper repair shops, or start sharing data with other insurers. The principle is exactly the same. You don't just note the problem, you respond to it. Look, this whole spaceship story isn't just a cool narrative. It's the perfect analogy for why monitoring is so important. And for any of you studying for the CP1 exam, quick heads up, this is a huge topic. And why? Because without this constant feedback loop, your models just drift. They become useless relics. And when actuarial models become useless, those big financial promises, the pensions, the insurance policies, can get broken. And this all feeds into the final and honestly the most powerful idea of the whole cycle. Monitoring isn't just about catching your mistakes, it's about learning. It is the engine that drives improvement and makes the entire cycle stronger every single time it turns. If we look back at our diagram, you can literally see how this works. See those arrows? The monitoring stage feeds back into everything else. What you learn from what really happened helps you define the next problem better. It gives you sharper, more accurate data to build your next solution. It makes the entire system smarter, more robust, and more resilient. Okay, so let's really nail this down and connect the dots between the story and the real-world concepts. That nebula dust in our story, that's any kind of unexpected environmental or economic change. The drop in the food supply, that's your classic experience variance. The dashboards the captain posted, those are your monitoring reports, your KPIs. Her decision to juggle power between shields and lights, that's a management response. And updating the model, well, that is the feedback loop in action. So let's leave it with this thought. You can be absolutely certain of one thing. Your models will drift away from reality. That's a given. That isn't the failure. The failure is not noticing it, not investigating it, and not learning from it. So the real question is, when it happens, what are you going to learn?